Okay, so next topic, P10 Electricity and Circuits. It's been a while since you've reviewed it in any detail, but you're pretty good at this topic. Even things like the grade 9 multi-step equations, you're pretty good, but it is an equation fest. So if I just quickly review some of those, remember you're going to need Ohm's law a lot. I'm very rich. You know that can then bounce into I quit to work out the charge in coulombs. You know that can then bounce into vultures, whip, queens, or I see pink rabbits. They'll tend to bounce it into one of those, or they can bounce it into IP violently. And remember, your work is the same as energy joules. Now, ultimately, I can combine these steps into the electrical energy equals current times voltage times time. And you can work that out yourself. If you were to follow it through, you'd see what's going on. So the electrical energy is current times voltage times time. You can see we looked at this one with the motor. Now, the only other little things that are a bit tricky, remember the total resistance in series is R1 plus R2, dot, 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 dot. The resistance in parallel with two things is R1 times R2 divided by R1 plus R2. And then the tricky one, the resistance in parallel with three or more things equals 1 over R1 plus 1 over R2 dot, 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 dot. That's the trickier one. All right. Now, your revision guides and things show it differently to this. I recommend in doing this because the one in your revision guide, you'll end up with 1 over RP on that side. And the number of students that forget to take the inverse at the end, I recommend you do that. But you do what suits you. So I'm just going to rub all of that out. So that's a quick blast through all of those equations. And if you're not fully happy with those, make yourself a revision cue card going over those in detail. Now, that is not an exhaustive list of the equations that you might need for this unit, but it's a great big chunk of them. Okay, first one. So what's the potential difference? So that's what's the voltage. It's given us a resistance here and a current here. So I'm going to need I'm very rich. And what it's checking is, okay, in series, those need adding up. The total resistance there is 30 ohms, and then we're away. So V equals I times R, 0.4 times 30 comes to 12 volts. Now you get a mark for calculating the 30. So one for that, one for that, one for that, one for that. Nice easy marks, really. Go on to the next part. Use the circuit diagram to calculate the current leaving the 3-volt battery. Now, it could even say arriving at. It's the same. What we've learnt then is whatever sets off comes back. I said try to think of it like a river. So I've got a flow of a river there. It can branch into smaller streams, but at this point here, it's going to go back into the river to come back in terms of this total charge flowing around the circuit. So ultimately, we've got resistances here. It wants the current and it tells us the voltage. It's Ohm's law again. But we're going to have to just work out the current for that branch, work out the current for that branch, and then add the two together. So here's the answer for that one. I equals V over R, 3 over 6, 0.5 for this first branch here. I equals V over R, 3 divided by 1.5 equals 2 amps here. I usually say it's a good idea to, if they give you information in the question here, add it to your diagram. And then last, add those two together, 2.5 amps. Done. Next one, what's the total resistance for 4 20 ohm resistors connected in parallel? So we're going to need that formula. Total resistance is 1 over, and it's 1 over 20 plus 1 over 20 plus 1 over 20 plus 1 over 20, because there are 4 20 ohm resistors. That's the equivalent of 4 over 20. I appreciate I could have simplified that to 2 over 10, but I wanted to just show where that's come from. Put that into a calculator, and we've got 5 ohms. You can see a lot of calculation to do for just one mark. The next one, what is the power of the bulb? If 4 amps, so I've got a current, I. I've got a voltage here, and it wants the power. So this is going to be IP violently. So going on to that one, P equals I times V, 4 times 3, 12 watts, 12 joules per second. On to the next one, 4 volts of potential difference provided a current of 80 milliamps. Okay, so I've got to divide you by 1,000. What is the resistance? So I've got volts, resistance, and current. Oh my days, it's Ohm's law again. R equals V over I, 4 divided by the unit change, 0.08 equals 50 ohms. Next one, explain why the total resistance decreases when the same resistance components are put in parallel. So ultimately, if I start adding things together, the resistance goes up. However, I can, as soon as I put them in parallel, I am likely to reduce their total resistance. And here's your model answer. So there are more pathways, there are more routes for electrons and charge to travel. Next one, tricky question. The following graph shows the potential difference in current. So I can see I've got potential difference on the X. I've got current on the Y. The X-axis, each of these going up is 0.5. The Y increment is 0.1, so each of those is 0.1. And it says calculate the resistance, and I'll just change my colour here, at 1.5. So 0.5, 1, 1.5. I've got to calculate the resistance here. And I can see that because it's a non-linear relationship, this resistance is changing all the way along there. So the crucial part now, as you do in chemistry, we're just going to take a tangent to the line. Once we've taken a tangent that's roughly, and I'll do a dodgy one here, that's roughly at the same slope, I can then draw a triangle, and then I'm either going to do y over x or x over y, depending on what we're looking at. So I'll tidy all of that up. So the first part is, we can see I've got I, V, and R. So this is Ohm's law. So it wants the resistance R equals V over I. So V is here, that's on the x-axis. Current's on the y-axis. So for me to find any gradient, I need x divided by y. Now, most of the time in physics, it's y over x. But you can see, got to think about this problem. Sketch a line. So that's roughly right. And then it's the gradient is the change in x over the change in y. So here we can see, well, what have I done? I've made it easy for myself. I'm going to draw a little triangle there. This change is roughly 1.5. This change is roughly 0.2. And I'm going to do 1.5 divided by 0.2. So the resistance is 3 ohms. Lovely question, but pretty tricky. It then says describe and explain the shape of the graph. So if you'll remember from last year, I got you to dance these graphs. So we had a resistor at fixed temperature. We had a filament bulb, which is the Egyptian one. Remember I said, don't curl it up there. It's got to be nice and flat. We then looked at a diode, and then we looked at the light-dependent resistor or the thermistor. So looking at this, I can see, yep, this is a filament bulb. So now we've got to explain it. And what you learned was, well, it's a potential difference. So describe as potential difference increases, current increases. We can see that is the case, but it's a non-linear relationship. So over time, it's going to start to level out. Now we've got to explain that leveling out, and it's that the as we're passing the voltage through, the electrons are hitting the positive metal ions and causing the temperature. As the temperature goes up, resistance goes up, and therefore less current can flow. So at higher voltages, the temperature increases, so resistance increases, and the line levels off. But it's that idea. Temperature goes up, resistance goes up. So with the same push, I get less current flow. Next one, nice question this. Calculate the potential difference between points A and B to two significant figures. Now, what I'm going to do is I'll show you how to work it out for A and B, and also if we wanted for B to C. So the crucial bit is I've got to change these to ohms. So milli divide 1,000, 0.5 ohms. Kilo times 1,000, and I've got that. And to calculate any of these, I need my total of 4.5. And the way these always work is it's always what's the resistance of your component, or the place that you're looking at, divided by what's the total resistance, multiplied by whatever the voltage is that you put in. We can see the voltage we put in is 24. So to calculate this part over here, 0.5 divided by 4.5. So you are 0.5 at a total of 4.5. But remember, that step's important. Multiplied by 24. If I wanted to do the voltage share there, well, that would just be 4 over 4.5 times 24, 21.33. So I can see, yep, we've answered that. I mean, another way of getting this is we know we've got 24 and we found out this share. I could just take that away from 24 and it would have given me that. But You're going to need that in terms of, and I think in your revision card it's called potential dividers. So just make sure you're quite good at those. And that's it.